Okay, so in this lesson we're going to continue to look at circular motion, and we're looking at various examples of objects that will be moving with this nonlinear or circular motion. So for example, the first case is a satellite that's orbiting the Earth. This would equally apply to the Moon, which is orbiting the Earth, as you well know, and both these objects move with what is basically a circular motion, and the velocity of the satellite is indicated by the red arrow. Okay, and you'll see that although the satellite is moving with a constant speed, because its direction is changing constantly, that means its velocity is changing. Okay, and as we learned in the previous lesson, because its velocity is changing, that means it is accelerating. And because it is accelerating following Newton's second law, then there must be a force acting on it which is enabling it to accelerate, which is enabling it to move in this circular motion, and that force is always acting towards the center of the circular orbit, and in this particular case the force is provided by the gravitational field of the Earth. Okay, it is the force of gravity which provides the centripetal force which enables the satellite to move in a circular motion. So I want you to think about, when you're thinking about circular motion, you've got to think about what force provides that circular motion, what force enables that circular motion to happen. So the force is provided by the gravitational field. Let's have a look at another situation. This time a car driving around a bend in a road. Okay, so here the car is moving in a linear direction, but when it hits the bend, its direction becomes non-linear. That's to say, it moves in a curve. Again, that means its direction changes, that means it's accelerating, that means that a force is required in order to allow it to move in that circular motion. What provides the force that enables the car to do this? Well, the only thing that can do that is the friction between the road surface and the tires of the car. Okay, so it's very important that in order that the car can travel around this bend safely, that friction has to be sufficiently large in order to provide the necessary centripetal force. Okay, so it's very important that the road surface is in good condition. Okay, you don't want sand or gravel or whatever it is over the surface of the road, or mud. And also that the tires are in good condition. They must have a good tread, right? So if the tread of a tire starts wearing down, then that would reduce the maximum friction that the tires of the car can provide. So that could endanger the driver and passengers. So if the frictional force provided by the tires and the road surface isn't enough to supply the necessary centripetal force to enable the car to move in this circular motion, the car will skid off of the road, right? Because the friction isn't sufficient to maintain it in a circular motion. So what factors affect the size of this centripetal force that enables the car to move in this circular motion? Well, there are two important factors. First of all, it is the speed of the car. Okay, so you well know that if you're coming to a dangerous bend, if you put your foot on the accelerator and start traveling a lot faster, you're going to increase the chances of skidding off of the road. Okay, so the faster the car is moving, then the greater is the centripetal force necessary to help maintain it in that circular motion. So most bends will have a speed limit telling you to slow down. They're telling you to slow down to reduce the velocity, because this reduces the size of the centripetal force necessary or required to keep the car on the road. So if the car is going much faster than this speed limit, the friction is not enough to supply the required centripetal force again, and the car could skid and have an accident. The other important factor which affects the size of the force required to keep the car in this circular or nonlinear trajectory is the tightness of the curve. Okay, so we can say that the tighter the curve, then the greater is the change of direction. And consequently, the greater is the acceleration of the car as it goes around the bend, and as a result, the greater is the required force necessary to keep the car moving around this trajectory.